Okay, this is the first part of class for tomorrow. This will be my first video. I'm going to solve problem 1, um, number 27 from chapter 5 of the book. This is basically the problem. They wanted to recreate this graph using this formula here. Okay, and you're given some basic constants. C equals 3 times 10 to the 8th meters per second. That's the speed of light. H, Planck's constant, K, and so on. Okay, so what I've done is I've got this formula, and I want to do it for 3 different T's: T at 3,000 Kelvin, T at 4,000 Kelvin, and T at 5,000 Kelvin. So what I've done basically is I've put in figure 1, okay, and in each case, I've put in each of the constants as they were given in the problem statement right here. And it's probably not a bad idea to run this just to make sure that there's no mistakes in here. This octave GNU is a little bit finicky, I would say. So it's probably good that you run some of this as you're going along. Okay, so I need to calculate a timeline, so to speak, here. Okay, that went along with that plot. Let me just show the plot one more time. Grab that. Okay, that's the plot. Goes from 0 to 3, and the wavelength is micro meters. Okay, so I'm going to create that constant. Okay, here. Okay. So LM plot, I'm going from 0.1 to 0.05 in 0.05 increments to 3. I could have done this with Linspace as well. And then I'm going to multiply that times 10 to the minus 6 to make it micro. Okay. And then I'm going to make my calculations for the 3 different plots that I'm going to have. Okay, and so I have T1, T2, and T3. I created R1, R2, and R3 and did the calculations in accordance with the formula that I originally had started with. Let me just go back to that. That's this formula right here. Okay, I'm plugging that formula in, and every time that I do this, I probably should, I've got them all semicoloned out, but I would get an error otherwise. If I look back at my window, there's no errors. Of course, I did this beforehand. That's how I'm getting the typing doing, making that go so quickly by cutting and pasting. Okay, I'm going to create a plot, okay, and I'm going to put them all on the same plot, which you can do pretty easily. And this works the same way in MATLAB. This code, you can cut this code out and put it directly in MATLAB. For those of you that have MATLAB, it's not an issue. You can go ahead and cut that out. Now when I run it, I got my basic, that's my basic plot. It's got all 3 pieces to it. It's got, I did them all in black, okay, with 3 different line types, as you can see here. And now I'm going to make the plot look nice. I really expect you to do this. Take your time and make the plot look nice with legends. So I put the grid on. I did my X label, my Y label, and my legend. And I did put a handle on this legend. Let me get rid of this. I don't need that twice. Okay. I did put a handle on my legend, and then I changed the font size, and that seems to work okay. Not every one of these commands is perfect in the octave GNU, okay? And you look, that's a pretty good looking plot there. Now, if I want to change this into a PDF, I've got to go through a little bit more than I do with, kind of nice with the, when I have MATLAB, I can just directly convert it into a PDF. Here, I've got to capture this screen, which I do by just simply, on the Mac, I just make a screen capture, and then I take that and save it as a PDF. On the PC, you'll do a screen capture. You throw that using Control-C into Paintbrush, and then from Paintbrush, you can save it as a PDF, and then that PDF can be uploaded for me to look at to see where you're having problems. You can always put comments in there and stuff like this. I think this will work pretty well. It's not going to be a perfect solution. MATLAB would make it a lot easier. But if you don't have the $50 for the MATLAB, I completely understand. So this is a temporary solution, but we'll have to go with this for a while.